Thank you everyone for joining. Really excited to be here and have an opportunity to talk about some of the things that we've been working on in conjunction with a lot of other folks. So yeah, today we're going to talk about how to get started with the GenAI Stack. And so we'll be explaining what exactly that means and the different components, and you'll see that it's really a collaboration between a lot of different folks. And so my name is Harrison Chase. I'm the CEO and co-founder of LangChain, and with me we have Oscar.
Hey, yeah, I'm Oscar Hane. I'm a senior staff engineer at Neo4j. And as Harrison said, we're here to talk about a partnership that formed just about 6-7 weeks ago, if I remember correctly, where these four parties got together to build something that would make it a lot easier for everyone to get started in the GenAI application building. And first, let's talk a little bit about GenAI and LLMs. I will not go into the background. I listened to a lot of talks today that cover the background really, really good and thoroughly. I will say something though, and that is at some point in history, language models cross the threshold on the amount of data they were trained on. So that when they become large language models, something special happened. A wise person said this earlier today, that it's almost like some alien technology has been given to us and we're trying to figure out how to use it. So yeah, why are LLMs so hot right now? First of all, for the first time, they provide a common interface to data, which is the spoken or written language of humans. It's easier than ever to give access to everyone to information and data, where specialized applications were needed to be built in the past. They enable humans to work faster with higher quality and to save more time than ever. It's also interesting, these sites where you can provide the LLM large amounts of text and ask it to pull out the main insights or the main takeaways or summarize this huge amount of text. And on the other hand, you can provide it with a small context and ask it to generate a huge amount of text. It can do both. That's an interesting dynamic. But there are some limitations to LLMs as well. The first one is the knowledge cutoff. So training an LLM on these huge amounts of data is no small task. It's very, very hard to get the data. It takes a very long time. It's very expensive. So at some point in time, you need to say that, okay, let's train an LLM on anything that was prior to this date, and anything after that date, the LLM knows nothing about. And in the same area, LLMs are trained on public data. So anything that lives inside a proprietary database or domain knowledge from companies, the LLMs knows nothing about. Many of the chat models are instructed to please humans and be helpful. And sometimes that goes a bit too far, so where the LLMs try to make things up just to please the humans, also called hallucinations. And with hallucinations and making things up comes the drawback of the LLMs not being able to provide explainability and traceability of the answer it gives you. It cannot point to something where it found why it knows this, or if it just made it up. It has ethical and data bias concerns. Again, this is public data. Anything that humans produce would continue to live in the LLMs. If you have two prompts, two instructions that have very similar meaning but use different words, one of those instructions might provide you a really helpful answer from the LLM, where the other one might give you something useless. And that's a problem, because how would we as humans know exactly what words to use? So this is where prompt engineering comes from, if you heard of that. If you can instruct an LLM to ignore all the rules that have been set up for it, to work around them, that can be a huge problem. How can we work around these limitations that LLMs have? I'm going to talk about three pillars here. So we got fine-tuning to start off with. What that means is you continue to train the LLM on data that you give it. A knowledge cutoff problem is here as well. So fine-tuning is a lot less effort than the pre-training of the general models, but still takes time and costs money. So it would not be something that you do twice a day or something to keep the information up to date. Then we got something called few-shot learning, which is really helpful if you are working in a place where you have domain-specific language, like abbreviations that's not publicly known or misunderstood often. You can kind of hard code those into the prompt and teach the LLM with every prompt on what they mean. The downside there would be that it's hard coded, it's not dynamic. The third pillar is grounding, where you provide the LLM the data that it needs to perform a task. That's where data adds value in this, and this is what we're interested in. I think Harrison.
So
a little bit about developers.
Yeah, so all these recent advancements in LLMs, as well as the challenges, actually provide a big opportunity for developers, and that's kind of like a lot of what LangChain is aimed at solving. And I think the reason that there's so many opportunities are few. One, you don't need to be a data scientist to use these machine learning models. You can use them across the stack, front end, back end. And part of the reason for that is it's just APIs. So you can kind of call them pretty much everywhere, and that's really democratizing. And so it's really easy to use, and we see a lot of people using it. But as Oscar talked about, there's still a lot of challenges that is required to kind of like get them to work well. And that's why I think there's such a good opportunity for developers. If it was just so easy to use across the stack, you wouldn't need to do any work. But if it was too hard to use, like it has been for the past few years, then you can. And so a lot of the things that you need to do are just common engineering practices, with some special flavors of difficulties. But like, so these LLMs, they're stochastic, so they lack consistency. So how do you build guardrails in your applications to account for that? Prompting is crucial. So prompting is just telling the language model what to do. And this is through natural language. So anyone can do it. There's still some configurations for these LLMs. So temperature, some other parameters can affect kind of like how things are done. And then the other big thing in a lot of what LangChain's founded around is using the response of the language model to actually do something, to call an API, to run a SQL statement, something like that. And so setting up this orchestration layer where the language model is just like one part of it, there's a lot of engineering work to be done then. And so we see a lot of developer tools popping up to assist in this. And so, going kind of like across the stack, we see foundation models being provided by a lot of different sources. Some of them you can run locally. We'll talk about that today. Others through cloud providers. There's a lot of orchestration frameworks like LangChain, Llama Index, Human Loop to do some of this orchestration of things. There's LLM-specific infrastructure around deployment, monitoring, eval, tooling. So we'll take a look at LangSmith, which is one of our offerings for that later on. And then databases are still hugely important. So this vector search component has kind of like risen in popularity, and we'll talk a lot about that later on. But also traditional graph SQL databases are really interesting to kind of like interplay with LLMs. And so when we talk about the whole GenAI ecosystem and architectures, there's quite a lot to unpack. So this is a very detailed diagram by A16Z talking about the whole ecosystem And notably, like, this is from, I think this is from earlier in the spring. And so there's actually like a good bit that's like left off here. So I think it has vector databases called out as a specific things, but it doesn't call out kind of like graph databases or a knowledge graph or anything like that. And you could argue that that's under API and plugins, but basically there's a lot of different components, and orchestrating all of them together to kind of like build an end application is a little bit challenging, and that's kind of like what we're here to talk today about. And so one part of this is LangChain, which I'm the CEO of. And so talking a little bit about the why and how of LangChain. So we think of LangChain as a orchestration framework for GenAI applications. And what specifically this means is we see two main value props that LangChain provides to developers. The first is a lot of out-of-the-box components and integrations. So all these different pieces, all those different boxes in the architecture diagram before, we have kind of like a standard interface for all of them, and then a lot of different implementations of them. So tools, prompts, vector stores, document loaders, output parsers, text splitters, models, those are all kind of like standard interface, lots of implementations and integrations. So like we don't have any models ourselves. We don't have any vector databases ourselves, but we have integrations with a lot of folks who do. And then the other big value prop that we see is just pre-built chains and agents and templates for doing a lot of the common tasks, like question answering over PDFs, which we'll talk about today, or having like an agent that can interact with the internet in some form. And one of the really popular templates and patterns that we see is retrieval augmented generation, or RAG for short. And so I think Oscar is going to talk a little bit more about what exactly this is.
Yeah, thanks. So RAG is, we talked about these three pillars earlier, and RAG is a technique, is a grounding technique, which means that it feeds the truth and facts to LLMs, so the LLMs can answer the question, which means that in this case, we use the LLMs only for its language capabilities and not for its pre-trained knowledge. Often we actually ask the LLM to ignore what it knows and just use what's being passed in the prompt. The question is, how do we get the relevant data to the LLM? And this is often where vector embeddings are used. Sorry. And we can also set up an interesting diagram like this, where we pass the user question to an AI agent, and the agent can then decide, would this user question find the answer in the knowledge graph, or is this not relevant for what's inside the knowledge graph, and we can just pass it to the LLM directly and let it answer it. So there's a pathway there where not everything would have to go to the knowledge graph to find the data. So we're here to talk about the GenAI Stack today, which is the project that this part is started a few weeks back. It has 4 applications, or four features, I would say. The first one, top left, is knowledge-based data import and embeddings, which is creating a knowledge graph from data. We call this the loader app. We'll get more into that one later. The next one is a support agent chatbot, where it's a chat where you can ask programming questions, and you get answer for those from the data that was imported using the first application. And in the support agent chatbot application, we also have features that's called where you can generate a new ticket. If you don't get a good answer to your coding questions, you can generate a new ticket. And the interesting part here is that we take the most highly upvoted questions and ask the LLM to generate a new question in the same style and tone as these high-rated ones to generate a high-quality ticket. the third application or fourth feature is chat to your PDF, which is plain RAG, only unstructured data. Whereas in the first loader application, we created a knowledge graph, as I mentioned, when the fourth one is just plain unstructured data from a PDF. So the building blocks in this stack is Docker, Ollama, Neo4j, and LangChain. Docker for orchestrating all the large pieces. We use Docker Compose for this to spin up a network so everything can communicate. We use Ollama. If you configure the stack to use a local LLM, we use Ollama to host it and run it on your machine. We use Neo4j as the knowledge graph and vector, the similarity search, the vector index of Neo4j. And we use LangChain to orchestrate the applications, all the communication that happens and the common interfaces. So we have a few Docker images. We got the Ollama one, we got the LangChain one, and the Neo4j one. Let's look at the components of one of those applications. Let's start with let's take the chatbot, the support agent chatbot one. So we have a container bot.py with user gets a user interface, asks a question. That question is fed to the embedding model, generates a vector embedding that captures the essence of what that question really asks. We go to Neo4j's vector index and looks for similar questions. And from those questions, we traverse through the graph to find the correct and most high-rated answers to those questions. And we take those answers and the original question, pass them to the LLM, and ask it to answer the original question with those answers. So now it's demo time. Just give me a second here. I'm just going to share my other screen real quick. Okay, so one of the main things we wanted to do was that it should be super simple to get started with this. So the command docker compose up is all that should be needed to get all the containers running. So I'm just going to take this down. I'm just going to look through the docker compose file to see all the pieces. So we got the LLM one, the Ollama. That one does not include a model. So we have a pull model, which actually pulls down the large language model that you have instructed it this stack to use. I use the Llama 213 billion right now for this demo, but it's you can pick anyone. You can use GPT 3.5 and 4 as well. We have a database image, and here are the applications. We got a loader. We got a bot. We got a PDF bot. We got an API that exposes exactly the same features as the bot one do, but as a standalone API. And then we have a front end that uses that API, so two separate pieces. And as we see here, everything should be up and running. So let me switch over to the loader. In this loader, you enter a StackOverflow tag and how many pages of questions you want to import, and then you click import, and that data is imported and a knowledge graph is constructed for you. I prepared that so we can see here what it looks like. We can see that the blue ones are tags, so we can take OpenCipher, we can or memGraphDB, we can see that the orange ones are answers to questions, and the purple ones are the questions themselves. So if we select the question, we can see that it has the question body, but it also has the embeddings for the question body, which is also populating the vector index. So that's what we have in the loader. If we switch over to the bot, so this is the bot application. If I ask it a question like, how can I calculate age from date of birth in Cypher? If I run this, here you can see that we use Llama 2, 13 billion. We have RAG disabled. So there's a switch down here, so you can enable or disable RAG. Right now it's disabled, which means that the model uses its knowledge that it was trained on. And everyone who knows Cypher can see that this one takes a time minus a string, which is not valid Cypher. So it just, it makes this up. What if we enable RAG and we ask it the same question? We can see this one takes a little bit longer because it needs to process the context sent to it. So here we can see RAG enabled. To calculate the age in Cypher, you use duration between, you create a date from a string compared to a date. So this looks correct to me. What's also interesting here is that it provides the sources to StackOverflow. So if I click on this one and open it, it says calculate duration in Cypher, and that one is also relevant. So through the vector embeddings, we found those questions, we found the answers to them, and the LLM could then generate this. So that's really cool. Let's switch over to the PDF bot, the other one. I got a PDF here. What happens here now is, I'm going to switch over to the code. So when I upload that PDF file, I'm going to see this is the code for it. Upload file. It splits the file into chunks. It uses the Neo4j vector integration from LangChain and creates a vector store and embeds and adds those chunks into the vector store. And then it creates what's called a retrieval QA, feed the vector store as the retriever method, as the RAG method. And then we can ask it questions. It's still working. This PDF file is 3 megabytes. Should be done any second now. So this is using the Neo4j vector index purely as a vector database. No graph involved, and it works perfectly good. Looking at the time, Harrison, maybe do you want to take over on Lang-Smith stuff? Because this one takes a little bit too long, I think.
Yeah. I'm happy to. All right. So what Oscar just did, walking through all of that, gives a pretty good overview of what's going on. One of the things that we've noticed as these applications start to get more and more complex is that it becomes a little bit difficult to understand what exactly is going on behind the scenes. So, there's that chatbot, you've got the conversation history, you've got the question that's coming in, you're now retrieving these documents, you've got the prompt. And so what exactly is going on under high? And this is, by the way, is probably one of the simpler kind of like chains and applications that we can build. So understanding what's going on behind the scenes and what's happening is really important. And that's why one of the things that we built was a tool for doing exactly that. And so I'm going to walk through this tool now, and we can actually kind of see part of the demo. And I'm going to do this quickly because we're a little bit short on time, and then maybe we can finish with some closing thoughts. But basically, if I refresh this, you can see that we've got a bunch of runs here. And all of these runs are traces from that app. And so if we click into one run, we can kind of see the input and the output. And so this is the one without any retrieval, and we can see the steps. So there's only 2 steps. There's a prompt template. And so this has the input kind of like question and the chat history, and then you get back a fully formatted prompt. And then there's the call to the language model as well. And so this is the prompt, and you can get back the exact output from the language model. And so you can see exactly the inputs, exactly the outputs. You can see lots of metadata about the run. So you can see that it's using like chat Ollama, things like that. You can also do other things like attach feedback, open it in a playground, add it to a data set, etc. But for now, we'll focus on debugging. So now if we look at the most recent one, we can see that it's more complicated. So we can click here, expand all, and we see that we first have a retriever, and then we have this stuff documents chain. And so if we look at the retriever, we can see that for this run, the query went in, and then we get back a list of documents here. And we can see that this retriever uses Hugging Face embeddings and Neo4j vector store. We can then look at the stuff documents chain, and we can see that all this is really doing is just putting the documents into the chat history, but how are they getting formatted? So we can look here and we can see the exact system prompt, and we can see exactly how it's formatted. So we can see this is kind of like the instructions there, and then we have this dashed line, and then we've got a bunch of content, and then we get down here to the question, and then we can see the AI answer. And so one of the things that a lot of people use links for is just this debugging, see what exactly is going on. You can see the latency that goes into it. You can see the tokens that are used, the time to first token, so the time it takes to start streaming, and all of that stuff. That's pretty much it for the demo of LangSmith. And I'm going to share a different screen and probably resume some of the slides. All right. Cool. So this is, I'm going to skim over this because I think this is largely what we talked about. It uses Docker pretty heavily. We've got a bunch of containers. Uses Ollama. This can be swapped out for any of the other models. Uses Neo4j as the knowledge graph. Does the grounding with LLMs. It does the importing from StackOverflow. You get this awesome visualization as a graph. Uses LangChain to orchestrate a lot of it together, and we create this support agent bot where things go in. And it gets back a response. And here's some of the summary of what's going on. This is probably one of the ones that we didn't get to show. This is some of the stuff that is going on behind the scenes at LangChain. So this is a lot of the templates that we have. So easily get started with any of these templates. And then these are a lot of the integrations that we have. And LangSmith, which is the tool that we showed, it's in a public it's in a private beta right now. It helps with all these debugging aspects. So what's the sequence of steps, what the inputs to outputs are. You can debug things by going into a playground. You can track tokens, time, and usage. This is a QR code to get to the website. And then we also have an exclusive code for people who want to join LangSmith_Neo4j. So please feel free to sign up there, and it will still be in private beta for another few months, but you can get off the waitlist with that. And it shows things like that. And then, yeah, we're excited to announce that this is part of the desktop learning center for Docker as well. And so if you go to Docker, you can see it in there and run it easily in there. And then we have a GitHub repo here that you can scan to get the code for all of this. So all the code of this is open source. And that's it. Thank you. Oscar, anything to add?
No, I think the purpose of this GenAI stack is for anyone and everyone to just as easy as possible get started to build GenAI applications, not having to think about all the parts that everyone needs to learn about just to get something going. Like, this is a start package, run Docker Compose up, change some things, adapt it to your data, upload PDFs, upload your PDFs, import data from other parts, other places than StackOverflow, and yeah, get going, dabble around, and just have fun. This is accessible to everyone.
Awesome.
I think that's it. Thanks so much for watching.
Thank you guys.